All right, so today we are going to be talking about how we can use skills we've already learned in math class. You learned this in geometry last year probably. How we can use those same skills and ideas and equations to help us understand physics problems. But the first thing we're going to do is just orient ourselves to a right triangle and make sure that we know how to identify all the critical parts. So anytime you have a right triangle, oftentimes what you'll see is the box in the corner. That tells us that this is a 90-degree angle, which is what makes it a right triangle. If you go across the triangle from the 90-degree angle to what we have here, the longest side of the triangle, that one is the really important side for us to know. It's got a special name, and that is the hypotenuse of the triangle, right? It's the longest side. And it's always across from that 90-degree angle in this kind of triangle. In physics, sometimes if you're being asked to find the hypotenuse of a triangle, they're going to use different words. They might use the word resultant, especially if we're looking for a velocity from two vectors, or they might use the words displacement, okay, if we're looking for that directional distance vector. So it's a vector. We are going to use right triangles to help us solve vector problems. All right, so hypotenuse always is going to be this side across from the 90-degree angle. The adjacent leg and the opposite leg has to be defined based on whichever one of our other remaining angles that we're going to be looking for. So let's say that I want to look for this angle. I want to know what that one is. So now based on that angle, I have to think about which one is my adjacent and which one is my opposite. The word adjacent means next to, okay? Then of course opposite means across or away. So for the opposite, I always like to think of this as like a bow and arrow. Like imagine you had a bow and arrow and you pull the arrow back, and if you released it, it's going to go straight across the triangle and stick in the opposite side. So if this is the angle that I've defined, then this would be the opposite side. Okay. And if this is the angle I've defined, then the one that's next to it, but it's not the hypotenuse, this would be the adjacent side. Okay. So in physics, there's these really famous kind of typical problems called boat problems, and it might say something like, you know, if an object travels so far in this direction and so far in this direction, what would be the displacement? And so you'd be trying to find the hypotenuse of the triangle. So that's how we're going to start using vectors to help us understand motion in 2 dimensions. Whenever we can draw a triangle based on what's happening in our story, we can use right triangle math to solve that triangle.